let's look at some properties of series. These should be getting fairly familiar to you. Suppose I have the sum of a sub n is equal to a, and the sum of b sub n is equal to b, and c is any real number. Then if I multiply each term of the sum of a sub n by a constant, then that's simply the constant times the sum. If I add two infinite series, then that sum is the sum of their sums. Similarly, if I subtract. Now, we can use the nth term of convergence. If the sum as n goes from 1 to infinity of a sub n converges, then the limit must equal 0. However, I want to point out that the converse is not true. Just because the limit goes to 0 does not mean the sum goes to 0. We tend to use this for the divergence test. If the nth term does not go to 0, then the sum diverges, which kind of makes sense. If you're always adding 1, then that sum can never converge. So let's look at this sequence right here. The sum as n goes to infinity, 2 to the n. Well, the limit as n approaches infinity of 2 to the n is infinite, so this diverges because the nth term does not go to 0. What about this one right here? The limit as n approaches infinity of n factorial divided by 2 n factorial plus 1 is 1/2. 1/2 does not equal 0, so this sum diverges. Even though the sequence converges, the sum diverges. Okay, now let's look at this one right here. The limit as n approaches infinity of 1 over n, oh, lo and behold, this is 0. But the nth term test tells us nothing. We can't say that this series converges or diverges. All we know is that the nth term goes to 0. Now, let's see if we can do a problem. Suppose a ball is dropped from a height of 6 feet and begins bouncing, and the height is always 3/4 of the previous bounce. Find the total vertical distance of the ball. Now, we're kind of showing horizontal distances here, but we're really not. Let's look at D1. The first distance is 6 feet. What is D2? D2 is, let's see, we're going to go up this amount, and then we're going to go down this amount. Okay, so this is the second distance. All right, so this is 12 times 3/4. Let's look at D3. All right, D3 is going to go up 6. Now I'm going to write it this way. Okay, so that's the up for D1, but it's only going to go up 3/4 of that. And then it's going to go down this amount. All right. So this becomes 12 times 3/4 squared. You see there's a reason we're doing this. By continuing this, you can see that the total distance traveled is 6 plus 12 times 3/4 plus 12 times 3/4 squared. And then if I were to do the next one, this would be 12 times 3/4, of course, cubed plus. So this is 6 plus 12 times the sum as n goes from 0 to infinity. See, I've got to play with it a little bit because I've got that first term. And this is 3/4 to the n plus 1. Now I need this just to be to the n because that's how I've defined the geometric series. So this is 12, so I'm going to factor 3/4 out. All right, so this is the sum as n goes from 0 to infinity of 3/4 to the n. All right, now I have a geometric series. This term right here is, so this is 6 plus 9 times the sum as n goes from 0 to infinity of 3/4 fourths to the end. Nice geometric series. So this is 6 plus 9 times 1 over 1 minus 3/4. So this is 6 plus 9. That's 4 minus 1, 3. Okay, so this is 4. So the total distance traveled is 42 feet.